Now it would be a good time for us to revisit an old friend, the fraction class, which we worked on a while back. And we're going to utilize some of the more recent techniques we learned to update this class. Before we actually do any of the work in here, let's take a look at the class itself to refresh our memories what this thing actually does. So we have a GCD, which is the greatest common divisor function. It is not in the fraction class itself, it's used by the fraction class. And the reason it's outside is because it could theoretically be used without the context of fraction. Then we have our fraction class itself. Now clearly we have a lot of comments in here, so the code is long, but let's take a look what we're doing anyway. So we have the init function, which assigns the numerator and denominator into the numerator and denominator properties. And then after those are assigned, it simplifies the fraction to make sure something like 8/10 becomes 4/5. We have an str, which prints out the object in numerator over denominator form. Then we have our properties. We have the properties for the numerator. As you can see here, it has for the getter, it's just a property decorator. For the setter, it's the name of the property .setter, and for the deleter, it's the name of the property .deleter. That way we can utilize the exact same name, numerator, multiple times. The decorator is what helps separate them. And then we have our denominator, which has the same three functions, essentially, to handle the getting, the setting, and deleting of the object. And then finally we have this property called value, which simply returns the double representation or the floating point representation of our fraction by accessing the numerator and denominator as such. Now we don't have to access it here using the double underscores. The only reason it's like that in here is because it hasn't been updated yet. So we will take a look at that as well. Then we have our operators for add, subtract, multiply, divide, true divide, and we discussed that previously, but if you wanted another recap as to why we have this true div as well as a div, this article here in the comment would be useful to take a look at. Then we have our equality operators. So we have equals, not equals, less than, greater than, less than or equal to, greater than or equal. That allows us to determine whether or not a given fraction object is the same as another one, less than, greater than, etc. We're also going to take a look at that by using something called the total ordering decorator, so we can eliminate many of these methods, but we'll get to that later. Then we have the simplify method in here, which allows us to use that GCD function to reduce a fraction from like 12/16 and make it something simplified. So let's run the code. Let's go back to the top. Run, run, run. Okay, so 12/16 becomes 3/4. 16/12 becomes 4/3. So that's where simplify uses GCD to determine the right factor to divide by to simplify the fraction. Okay, let's go back to the task at hand, which is to simplify or to change our properties from using a property to using descriptors. Okay, so to create a descriptor, we know we need to make a class. Now these classes are going to be relatively specialized. So what I'm going to do is I'm going to make these classes inside of our fraction class. So they'll be scoped inside of it. We can still use them externally, but if to get to them, we'd have to say fraction.numerator and fraction.denominator. Okay, so let's go ahead and change this, and we'll say properties, and we'll say using descriptors. Okay, then I'm going to create our class called numerator. I'll do that first. And we could call it numerator descriptor as well. Let's just call it numerator for now. And class numerator is going to have a get and a set and a delete. So we'll provide those three as such. So as you can see here, this is now the comment for it, the numerator of a fraction. We have a get, which returns the instance dot double underscore numerator. We have set, and if you look here, the rule is it must be an int. And if it's not an int, we automatically assign the value 0. So it's the same logic that was used in our setter here. It's just that we are now working with this instance variable instead of self. If we did self, remember self here refers to the descriptor class itself. So what we can do now is go through this entire thing for numerator and simply hit delete. And denominator is going to be very similar. It's going to have the exact same setup as numerator, as you can see. The biggest difference, obviously, we're dealing with double underscore numerator for accessing the value in the fraction object itself. And our logic is a little different here for making sure we don't have negative values for the denominator or 0 values. Now that one is actually considerably different. I'm actually going to delete the getter for now so I can put the two setters next to each other so you can see this code alongside this code here. So we still have to check to make sure the value is an int. If it's not, we simply set it equal to a 1. Otherwise, if the value is a 0, again, we simply set the denominator to 1. Now, if the value is less than 0, watch what I have to do here. I don't say instance dot double underscore numerator here. And there's a reason. It's because I want to utilize the property I just created here by using that descriptor. So I'm going to say instance dot numerator, which will call the getter from this descriptor. And then we are going to multiply it times equals negative 1, which guess what? Is then going to call the setter. The times equals 1 is really instance.numerator equals instance.numerator times negative 1. So we're accessing the getter and the setter all at once in that same statement. And then we set the denominator equal to the absolute value of the value passed in to make sure it's not negative. And then deleter is pretty much the same thing. We have the deleter, and we want to make sure that the denominator is just set to 1. So that's the correct way to delete that. And let me get rid of the rest of the denominator property code. So the only property decorator we're going to have is for the value. We could create another descriptor for that, but I figured I'd leave at least one of the old properties in here since it's only a single method anyway. We don't provide access to the setter, so this seemed appropriate to do. And then I'm going to then assign these descriptors to internal variables of the class. Again, there should be called numerator and denominator because they are replacing the properties of the same name that we used to have. So you can see how much less code we actually have now. And then if you look at the value here for the property for value, I'm going to get rid of those double underscores here because I have the properties, I might as well use them. So it's going to call the getter for numerator and the getter for denominator. Let's slide down and rerun this code and make sure everything still works. We still have 3/4, 4/3. Everything is working as it did before. It's just a far simpler set of code. I'm also going to change the str. No, actually it looks like str is fine right now. We're using numerator and denominator, so that's fine. Yeah, so that's it as far as the descriptors are concerned. But now let's take a look at some of these operators down here, where we have equals, not equals, less than, greater than. Well, one of the things you'll notice about this, equals defines whether or not two fractions are equal. What does not equals do? Well, it basically tests using the equals we created here and then returning whether or not it's not equal. So it takes the result of equal and just knots it, so it flips it from true to false or false to true. So in fact, it seems pretty straightforward. If you've defined equals, we don't really need not equals because it should be self-explanatory how one defines the other. And this is where we're going to get into using this total ordering decorator to help us eliminate some of the not needed methods. Also, take a look at less than. So this one right here determines whether or not a fraction is less than the other. But take a look at all the other methods I created. Greater than, less than, and greater than or equal to. Guess what? Greater than uses the less than operator in conjunction with the equals operator. Less than or equal is a not of the greater than operator. Greater than or equal is the not of the less than operator. So as you can see, just like not equals, we can define all of these other inequalities, or range equalities, however you want to call them, with just one of them, because they're all derived from less than. And again, this is what we're going to use total ordering for. So you need to go to the top of your file and insert a new import statement. We're going to be using func tools. We've used it before for other things, but this time we're importing something called total ordering. Then go ahead and copy that, because on the fraction class, we're going to provide that decorator. And I'll put a comment here indicating what this thing does. So it allows us to define only equals and less than, and then total ordering will scan the class when it's created, because remember what a decorator can do. It can monitor when this class is being created in memory. So you run the class, not create an instance of it, but when Python interprets this class for the first time, it will actually add the code for all the other operators. So now we can go down to the equals. We'll keep that, but we'll get rid of not equals. Just hit delete. Greater than, less than or equal to, and greater than or equal to as well can all just go away. So I've deleted them completely. So go back to the top and make sure we've run the import statement. And all of the code is still functional. We still have equals and not equals working. Notice the first one is false, the second one is true. That's the equal, that's the not equal. So that still works. The true, false are all the same, because F4, if we take a look at F4, which is hard to figure out which one it is, let's go ahead and, before we do this, let's print F4, and then F5, as such. Oh, did I forget the quote? I sure did. Okay, so F4 is 1/3, F5 is 2/3. So it's pretty obvious how they're going to be equal or not equal to each other. So are they equal to each other? No, clearly they're not. Are they not equal to each other? True. Is F4 less than F5? That should be a true. It is. Is the opposite true? Is F4 greater than F5? That's false. Is F4 less than or equal to F5? Yes, it is. Or is it greater than or equal to? No, it's not. So all of our operators are still working. As a matter of fact, if we were to print dir fraction, you will actually see that here's the less than or equal. Here is the greater than or equal. Here's the greater than. So the only ones we defined were equal and less than. Where's less than? There it is, less than. So all of the other ones are in here by virtue of using that total ordering decorator. And total ordering isn't necessarily just for making fraction classes work without having to define all the operators. The point of that is if you're sorting objects and you need to determine when you are scanning through the objects if one goes before the other, that's what total ordering was designed for, so you can come up with a stable sort. It just so happens to figure out if it needs to swap values, you need to define these operators to determine whether one object is less than, greater than, equal to another. And so the total ordering decorator is extremely powerful. And if you're creating a class that requires operators like this with the equals, less than, etc., there is absolutely no reason why you shouldn't use it, unless your code, for some very specific reasoning, which I can't think of anything right now, does require you to define all 6 of those operators separately. So that's going to wrap up our modifications to the fraction class. Hopefully you can see that even though we were able to create a complete fraction class before, we learned new techniques to make the class better. And this is something you're going to encounter in your entire professional career, is that there's more than one way to solve a problem. When I grade student assignments, I hardly ever see the same thing twice. That's why if I do see the same thing twice, that's actually, it jumps out at me as like very suspicious, because most people will accomplish the same result a different way. So this is just demonstrating we get the exact same results, but we just use a different set of techniques to accomplish it.